Hello, a very good day to you. My name is Ishan Mitra Haldar and my matric number is 201390. This is the presentation for the mini project of EAS 3215 Flight Mechanics. The title of this presentation is Mission Profile and Relative Analysis. First of all, what is the mission profile? A mission profile is a scenario that is required to establish the weight, fuel, payload, range, speed, flight altitude, loiter, and any other operations that the aircraft must be able to accomplish. So this is a diagram of a common mission profile of civilian aircraft. So we can see that there are actually two main parts. One is the mission and one is the reserve. In case something goes wrong during the mission, we need to have extra fuel to back something up so that the plane can go a little bit more. I'm just covering the aircraft mission profile. So the reserve fuel is generally 5% of the entire fuel, and it will also be shown in the calculations later. So for this one, for this mini project, I have chosen Airbus 320 Neo as the aircraft model. So these are the specifications that we can see, and the important one, the most important one, is the max takeoff weight, which is 174,200 pounds, and it is going to be used in almost all the calculations that I did for this mini project. Then when I was going through all these units and everything for these specifications, I was kind of curious to know how many units are used for aviation. So these are the standard units of measurement in aviation at the left side of the slide. And at the right side, we can see how we can convert between the English units and also the SI units. So after that, this is the mission profile one. In this one, we have taxi plus takeoff, then climb, cruising, loitering, descent, landing, and taxi. So for this one, the values I have calculated are takeoff distance, max rate of climb, max velocity for rate of climb, range, velocity, actually cruise velocity, endurance, landing distance. So we can see from the table that all the values and the comparison with the actual aircraft specification values, they differ very little, but only for the case of range and velocity, the cruise velocity, it varies a lot. So why is that? It is because for range, we have to find the distance for the cruise of the mission profile. But in this one, instead of taking the weight at 3 and weight at 4, I have assumed that the weight of 3 is actually takeoff weight and the weight at 4 is the empty weight. So the value I got is actually the whole distance that will be covered for the mission profile, while in the aircraft specifications, it only shows the cruise range. So the same can be said for velocity. During the takeoff, the velocity is accelerated a little bit more, so the average velocity becomes higher. That is the reason why the range and velocity values differ so much from the cruising range and cruising velocity. But for the other values, they're kind of close. We can say that because of some assumed values to calculate the final result, that is the reason why they vary a little bit. This is the mission profile 2. There are 8 phases: engine start and warm up, taxi, takeoff, climb to cruise, cruise, loiter, descent, and lastly, landing, taxi, and shutdown. So for this one, at first I was curious about how much will be the payload for Airbus 320 Neo. Airbus says this model only covers the short and mid distance travels. So I went for the short haul travel and mid haul travel for to get the payload values. The difference in the equations is only for the baggage. So the actual difference is not very much. Then I calculated the payload capacity, cargo capacity. So at the start, the weight is the takeoff weight. Then after the phase 1 ends, we'll get a little bit of decrease in the weight because the fuel is burning. then gradually at the phase 8, that is the end phase. That is the end of the mission, and it is the empty weight. We don't have fuel left. So it is actually 141,409.0629 pounds. And in the aircraft specifications, the empty weight was 141,800 pounds. So the difference is very, very minimal. And that difference is due to the what to say, the values we neglected, the values after the decimal points. That is because of that. So it can be deemed that the calculation was correct, and then that is why we got the empty weight as precisely as this one. So after that, I got the mission fuel fraction, only the average, then the fuel used. It is except for the 5% of reserve fuel, and lastly the fuel weight. It includes the reserve fuel too. So the total fuel that will be needed to complete this whole mission is 33,006.3158 pounds. That was all for this presentation. I hope I was able to convey my work in a very, what to say, presentable way. So that is all. Thank you very much. Have a nice day.